stop sharing because the other thing was popping up on top of it. There we go. Like how many people were in the waiting room was popping up. Sharing because the other thing was popping up on top of it. There we go. Like how many people were in the waiting room was popping up. Because the
Okay, I want to just
That's funny.
don't mind me. I just got a couple things to do before
Okay.
I have showtime here. Edit.
You look nice, Shelley.
thanks, you look lovely.
Thank you.
I hope you had a good sleep last night.
I did have a good sleep.
Good.
I was so tired. Were you?
Yeah, I was so tired, but I was very happy with what we accomplished. So,
Too. That was awesome. I can't thank you enough.
oh,
You, Shelley, helped me clean out my office yesterday. So, she can also be a professional organizer. Many talents.
flash drill sergeant.
You know, sometimes you need that, right? Sometimes you need that person to be like, you don't need this. And you're holding
Exactly.
on to it, and you don't really
Exactly.
realize
It
why
was
you're
like this, John. Do you want this book? No, we're going to donate it. Like you don't even get to answer the
perfect.
question.
Perfect. All right, let's get rolling here.
Perfect.
I'll do that after. You can see my screen. It says the title.
Yes.
All right, here we go. All right, folks. People are showing up. They're ready for fractions. This is what they came for. They're here. They're ready. They're ready. Folks, you're joining us. Welcome again to another session from the 2024 Make Math Moments Virtual Summit. I am John Orr. I'm one of the hosts, and I am just about to introduce our two speakers. I won't be speaking too much. I want to get a couple things out of the way. I've got a couple reminders for you. It's probably the same reminders you've been having in the other sessions. But get yourself in the chat. Look at that. Like they already know what to do,
That's
Shelley. They
amazing.
already know Tara. They're getting in there. They're letting us know where they're from. It's amazing to see people from all over the world. Last night it was like from the future. People were like, "I'm here, but it's Saturday," you know. So we've got that going on. So I'm seeing Alabama. I'm seeing Idaho. I'm seeing Colorado.
Lebanon.
Where are Canadians? Where are Canadians? I see Australia.
I
There's some
saw St.
Canadians.
Lucia.
The three of us folks are from Canada. So a couple of reminders. Here we go.
Here we go.
Just as a reminder, first reminder, the weekend is completely free all weekend long. If you need access past the weekend, go ahead and upgrade your ticket. You can always add a ticket to your account. Just go to the site where the replays are, where you click to get into this session. Certificates, make sure the certificates sometimes up in your certificate area, it might not be showing accurate, say, live results or live attendance. Don't worry, we will send out an accurate certificate Monday. No need to reach out to us. We know what the issue is. So don't worry, just wait till Monday. We'll get everything in order. If you're not sure who, say, I am, but we've also had our two speakers, Shelley and Tara, who I'm going to introduce in just a sec, on the podcast, on the Make Math Moments That Matter podcast. We put out a few episodes every single week. You can subscribe, you can listen to stories, ideas, nuggets of information to help you in your classroom or in, say, as a leadership role. Stick around to the end. We are giving out a Braining Camp license as a door prize. We'll randomly choose someone from the current list here who's joining us. So if you're here with us live in Zoom, you have a chance to win the Braining Camp 1-year license. So that's coming out. We'll do that at the end. But I do want to get right to it, folks. Let's talk fractions. Today we have Tara Flynn, Shelley Yearley, two wonderful Ontario educators. Done a lot of work around fractions at Trent University with Cathy Bruce. They've got a book, Rethinking Fractions. And we are so excited for them to kind of share their learning, their work with you. I know I attended a live session back in May with them at OAME conference. In the 1 hour we were together, it refreshes and helps me learn even deeper. So you are getting that here for sure. And we're going to dig in. So I'm going to turn things over to the two speakers. Ladies, it's all your show here.
Thank you, John. Welcome, everyone. This is new for us in terms of the scale. There are as of this morning, we're 9,616 people registered for this session, which is incredible. And, I thought, it's hard to feel a sense of community with how are we going to talk to 9,616 people? And yet I really do feel a sense of community here with you because you are the people giving up for us, it's Saturday morning, but I saw somebody in Australia who's at 3 o'clock. It's some other day. So you're giving up whatever time to come and talk with us about fractions, and that makes you our people. And so we really welcome you, and thank you to John and to Kyle for making this opportunity for us to kind of gather in from all around the world. It is thrilling. So thanks for spending the hour with us, and we hope we're gonna inspire some other thinking about fractions. And Shelley, you want to say hello?
Hello, I'm reading the comments and I'm looking at the poll responses, and I'm just so excited for the range of people in the group, both in terms of teaching and then also in terms of geography. And I see some familiar faces. Hi, Heather. And I see that some people are doing book studies with the book already. So this is very exciting. What a great way to spend Saturday. So without further ado, shall we begin?
Let's do it.
All righty. So I think you see my PowerPoint.
Correct.
And I don't know why I am clicking. There we go.
There we go. So just to say off the top that what we're going to be sharing with you today comes out of about 10 years of research with 10 partner school boards in Ontario. Shelley and I have been working, we started this research with Dr. Cathy Bruce here in Ontario in 2011. And so we've been working together to explore fractions teaching and learning, and how do we set up the environment and the learning to help students make sense, and adults to help ourselves make sense of fractions. We've been working on this for a long time, and yet we don't ever run out of things to be fascinated by and excited about. So we're really happy to share all of this with you as much as we can in an hour. And we're going to try to keep it focused so that you come away with something. Well, we're going to be referring to a book that emerged out of this process, but you're going to leave today with something to carry forward in your learning, in your teaching today. So away we go.
Okay. So we wanted to start off by having you do a little bit of mental math. And so we just have a, fake registration, because I think we could have added some zeros to the ends of these numbers, but we wanted to keep it reasonable. So you see a chart that shows registration for 5 days for a conference. And using your mental math without using a calculator, we'd really just love for you to take a moment and add that up. And I see some people are already putting the answer in the chat and their strategy, which is awesome too. So if you want to pop your strategy in there too, that'd be amazing. We'll just give you a couple minutes to do that.
So a lot of people landing around 90-ish.
Awesome.
Awesome. Do you want to chat a bit, Shelley, about to get the strategy talk?
Sure.
going?
So we were thinking, we sort of anticipated some strategies, and I saw some of these strategies coming up in the chat. The chat is like rolling. It's like a ticker tape on my screen. So one of the strategies would be to collect all of the tens values together and then collect all of the ones values together and then add those two numbers. And I saw some people doing that. Another would be to add friendly numbers, which I see Tiffany built 10 using friendly numbers. So find the pairings that go together to make nicer numbers to work with, usually tens. I did see some rounding, which we didn't anticipate, but that's also a very interesting and effective strategy, especially if you just needed an approximate number, not an exact number. And then the last strategy that we anticipated was that you might just do a rolling sum. So start at the top of the chart, add the first two, add the next, and keep going that way. Okay, so now we have another one for you. So we would like you to do the same thing, do some mental math and find the sum of these 5 numbers. We'd really love for you to do it mentally. But first, just pay attention to any physical or mental responses that you had to the fact that now there are 5 fractions on the screen instead of 5 whole numbers. And I see people are busy doing that, so I'll give people a second to do that. And you'll see if you're following along that we have mixed numbers and we have improper fractions. And we have some suggestions that maybe the fractions weren't very friendly at first, but then once you looked at them, you could see some ways to work with them. Panic. So we have, Tara and I included, have not had always had the most positive experiences in education around fractions as students and then also as teachers. So we want to change that. So here are some strategies that we saw people using in the chat that we anticipated. So using a common denominator, Fernando said that they did that, and we think that you could do that. I used this question recently for the first time in a very large group in Ontario, and a lot of people did that, but they did it mentally, so they just knew a half would be 15/30ths, and they had 15, and they just added that way.
That is a lot of work. Kristen just said that's a lot of work.
It is a lot of work. The other strategy would be to just realize that some of them were halves and some of them were thirds, and you could put those together to make wholes and then add what's left. So 2 wholes, and I see Sharon is doing some thinking like that. And oh, sorry, that was that one. And then the other one was just to sort of do a running tally, but that would be very challenging with this one. But to collecting, strategy of collecting the wholes is a little more friendly. So what we want to do is have students and teachers have fraction number sense so that they can use the flexibility that some of you used here in all their fractions learning and not just go to an algorithm or a rule or have a sense of panic when they see fractions. So we, through our research and and in particular in the book, really want to simplify instruction so that we can build that fraction number sense. And what we're going to share with you today are two simple strategies. They're not about more time, it's about more precise instruction focused on unit fractions and powerful representations. Do you want to do this one, Tara?
Yeah, we've alluded a little bit to the research, but just to give you a little more of a window into that, we were asking a big research question, which was pretty broad. What instructional strategies support junior and intermediate? For us, that's approximately ages 8 to 9 to about 14, 15. So depending where you are in the world, I know our grades may not line up, or our grade bands may not exactly line up with yours. But it's sort of the middle school and early secondary school years that we were looking at. And how do we make fractions learning accessible to students for whom it has not been accessible? And we would say we worked with hundreds of teachers. We were very fortunate to work very closely with dozens of teachers over the years, working in their classrooms, collecting data and analyzing it from over 2,000 students. So it was a large longitudinal study. And over the time, we really have come to feel that there is a particular form of math anxiety related to fractions, that even when adults and students feel pretty confident in math or pretty engaged in mathematics learning, when we introduce fractions, you sometimes get that groan we're familiar with hearing. Oh no, now we're going to talk about fractions. That's not everybody, but it is a phenomenon we see over and over again. So how do we make this accessible and make it make sense?
I want to say that we have the range of kindergarten to grade 12 in our group, but I also saw that we had some people who were working with college students. So I want to say, first of all, that I am a secondary mathematics teacher. So when I finished my career 5 years ago. I went back to the classroom to finish in the classroom. And I used all of this research with students from 9 to 12. I had multiple roles, but part of my role was supporting students who were struggling in mathematics across the grades. And also for the kindergarten people, I want to say we're actually doing more research right now on how kindergarten students think, and in grade 1 students, so that sort of 4, 5, 6 age group, think about fractions and what strategies would support their learning. And we are seeing that the two things, the focus on unit fractions and the proper representations, definitely help. So I want to reassure people, even though the book, it has this sort of narrow target, and it looks like our research question had a narrow target, we actually ended up working in classes K to 12, and even across subject areas. We worked in building construction, cooking, music classes as well. So there's lots of applications, and really the sky's the limit. So we're going to start by talking about unit fractions. And the first thing that you might be wondering is, what are we talking about when we say unit fraction? So a unit fraction is any fraction that has a numerator of 1. So 1/4, 1/5, 1/23, 1/100th, 1/256th. Those are all unit fractions. They are important because they are the base unit for any fraction. And so we want students to, first of all, understand that unit fractions are the foundation for fractions. And that's a piece that in Ontario and in most of North America has been missing from the curriculum and from the resources in general. We're going to talk later about kind of what's in the book, but I'll just say the book focuses on assessment. We're going to share a couple of resources with you. This question comes out of the book, So we just show you 5 containers. Each container has water in it, and we'd like you to write a fraction to show how much water is in the containers in total. And I'm going to get my
5 groups of 1/4, 5/4.
nice.
Yeah, it is pouring over.
Yeah, so I feel like that it is pouring over. People may be visualizing, combining them together. I feel like if you had it in front of you, you might be drawing some arrows,
Circles.
circling things. Yeah, yeah. So notice that to do this question, oh, nice. Chris says we've always done unit fractions, but they just color one piece in. So Chris, you're going to see today how you can expand that in such simple ways that are very powerful. So here, yes, we want students to recognize that the container, one of those containers is the whole, and we want to see if students actually understand about combining like unit fractions. So putting those unit fractions together, knowing that a fourth plus a fourth would be a half, and that 4/4 would make a whole. So they could see either physically by drawing arrows and circling, or by reasoning that they would have one whole jug and then a fourth of a jug filled in the other one.
A lot of people are making money connection, Shelley. And then Megan has said the problem is a lot of kids these days may not use coins very much because of the prevalence of cards. So maybe that's just something. I know we're going to circle back to representations, but maybe just tuck that in the back of your mind to come back to a little bit later.
Yeah, and I would say here that just notice that I called those fourths and not quarters, and the phrase quarters is somewhat ambiguous. We will come back to it, but fourths means fourth, and that helps them to see it's 1/4 of the whole, one of 4 pieces that are equal of the whole. So we're
Yes.
going to show you some unit counting, and you may have some familiarity with this or you may not. And if you don't, this might feel wrong or really uncomfortable. But I'm going to say that time and time again, even I was in a board on Thursday night with a group of teachers, and even then they were saying they cannot get over how powerful this unit counting has been for their students. So Tara and I are going to model this. And basically what you would do is in your classroom, you just have your students get into small groups. It doesn't matter the size, but 3 to 5 or 6 students is probably good. And then they pick a unit fraction. We'll model it with 1/6. And they're going to count, but the way they're going to count is they're going to count the count separate from the unit. So our unit that we're counting by is 1/6. And so for young students or for older students who you want to build that content knowledge, we really strongly suggest using a number line or visual. I saw somebody suggested blocks, I think it was, for counting. So some sort of visual that helps the students track and actually see what's happening. So Tara, do you want to kick us off?
Okay, I'm going to start counting by 6. So 1/1/6,
2/1/6,
3/1/6,
4/1/6,
5/1/6,
6/1/6.
7/1/6.
I should have done my whoop whoop.
Oh yeah, whoop, whoop. So you can play this like a game where you do something or have the kids do something to mark the whole. So we'll keep going. 8/1/6,
9/1/6,
10/1/6,
11/1/6,
12/1/6.
and then you can do if they're hyper, you just have them all jump up. It burns some energy. And then we just keep going. 13/1/6,
14/1/6,
and
15.
15/1/6, and so on. There is a lot happening in this little activity, but before we really get into unpacking it, we wanted to give you a chance to try it. So we have, for the first time, arrived at a strategy that we hope works for online unit fractions counting. So what we did was we made 4 groups. We want you to pick one of those groups. It doesn't matter. We want you to pick a unit fraction. We've given you some number lines partitioned, so you can just track with your finger along the count if you want. And the one thing I really, really want to encourage is don't mash it all together and do 1, 6, 2, 6, 3, 6. Keep that count of 1, 2, 3 separate from the unit. So we'll stop talking for a moment, and we'll give you, let's say, 3/4 of a minute to do some counting. So just pick a unit, pick a group, and pretend that you're the people that counting around.
And we will explain why we want you to kind of go with us, trust us for a minute on this separating the count from the unit instead of, like Shelley said, mashing together. So 1, 6, 2, 6. And I did see that question come up in the chat. Why not? We will explain that, our reasoning and our experience behind this. Did you say we were giving them 3/4 of a minute?
Yeah.
And go beyond 1 whole, obviously. We haven't
Yes.
said that yet. Fernanda.
Okay, so I see people are finished. There's lots of chat in the chat column. So let's just go ahead and talk a little bit about what you might do with this as a next step. And then we'll talk about why. So we want students to count. There's lots of different ways you can do this. So much fun. But we also have this game that we play called the landing game. And we think it's also really powerful for developing that fraction number sense. So you are going to do it. So in your fake group that you picked, but in the group that you picked off the screen, we want you to think about, if you were sitting in that group in your classroom, what unit fraction would you select that would allow you to count around that circle once and land at a number that's between, so you can't land on 1 or 2, we want between 1 and 2. So we'll give you a second to think about that. And maybe while you're doing that, I'm just thinking, as I see answers popping up in the chat, that we really think this is an oral activity. And so it gets a little confusing with the typing of the answers. I see people writing 4 1/3, and then I see people writing 1 1/3, but I think they mean 1 and 1/3. So just this is an oral counting activity. If we were writing it in a classroom, we might write the count in a word, let's say, and then a dash with the unit just to keep it separate from a mixed number.
Mm-hmm.
So we see lots of answers that meet the criteria, and then the discussion you could have with your students would be, for example, one of our groups landed their final fraction that they said was 5 1/4. And so first question is 5 1/4 between 1 and 2. And then second question, what do we know about that group? And we want students to say we know that they counted by the unit fraction 1/4. And we also know if they counted around once and landed at 5 1/4, there must be 5 people in that group. So you can have some nice discussions. I see people asking about the book and the website. We're going to talk about that a little bit later, so we will come back to that. So you can have very nice discussions with your students about their fractions reasoning with that. We'll come back to this game a little bit too. So now, let me go back a bit. We're going to use Canadian money, but so apologies to people who are from out of the country, but we just want you to count this money as it appears. And I wonder if Deanne is from the US. And the coins are dollars, $1. And so lots of people have arrived at $275. And we're just trying this. You're our first audience with this. But we wanted to see if this might help with some of the information on the next slide. So my suspicion is that as you counted, you didn't necessarily count 100, 200, 220, 240, 260, 265. I see some people who are on the camera shaking their heads. So I feel like you probably started to drop some of that information. So maybe you got to 200 and then you just said 20, 40, 65. And then once you started counting the ones, you probably just were like 60, like just 6, 7, 8, and you drop the 260 something. So we have these strategies that we use intuitively around how to manage units and quantities during counting. And we want students to connect that to fractions. So, oh, Laura says we could have wondered what it would be like to do it the other way. That would be interesting. So we had the opportunity to meet with a number of international educators and researchers early in our research, and they shared this information with us around the way that Asian students in particular are taught to think about calculations. So one thing that they do when they're teaching very young students and they're doing a question like 5 + 3 is they reinforce that the students are adding the 5 whole units and 3 whole units. And then they just ask them to add 5 and 3, which is always 8, and then come back and put the whole unit back on it. So my answer is 8 whole units. When we come to decimal numbers, I think this makes a little bit more sense. So if I have 5/10 and 3/10 and I want to add those together, I can just add 5 and 3 and then set the tenths units aside. And 5 and 3 is 8. And my unit was tenths, so my answer is 8/10. And the same thing happens with fractions. So this example is ninths, but I'm still adding 5 and 3, and it's still 8, and now my unit is ninths. And then as a secondary teacher, and we had secondary teachers involved in the research, and there was one woman in particular who just loved this part, that then when they get to algebra, the units are x. And so we can just set the unit aside in the very same way. 5 and 3 is still 8, and my units are x. And then we saw this happening when we did work. And, you know, as we're learning and seeing things happening in classrooms, we're going home and thinking about things differently too. So in the kitchen, we do this all the time. You don't worry about what happens to your teaspoons when you're trying to figure out how many you need. You just know you can add the quantity or the count and put the unit back on it. And same thing in the garage. So We really want students to see mathematics as being seamless across the number systems, and this helps students to see addition across the number students is the very same no matter what you're doing. And we do have that question about students getting confused with mixed numbers. And so again, I tried to leave some space between the 5 and the 9th. And we would want to talk to students about that and be clear that that is not 5 and 1/9, it's 5 1/9. And so that use of the word and to denote the decimal location is very important. Okay, lots of stuff coming up in that. Yeah, it transfers to other contexts as well. I would not say 5 of 1/9. I just saw that pop up. Of often means multiplication, and so then that would mean that they were, I guess that is technically correct. 5 times 1/9 is 5/9, but I feel like I would just read it as 5 1/9 or 5 and 1/9, which tells them it's a mixed number. Okay, Tara, I think you're gonna do this one, right?
Yes, and Stan's saying, would it be better to write numeral 5 and then write out the 1/9? That's exactly what we're suggesting. If you're moving this from an oral counting strategy into some written representation to separate the count from the unit in that way is super helpful.
Yeah. So we sometimes write this, or we write this. Let's see. So can you see that or not?
Not
the best color of pen I have. Sorry, 5, the word 5, the symbolic representation, or the number 5 and the words for the unit. Yeah.
Okay. Yeah. Okay. If you do start with, well, let's talk some more about counting, because if we think to our experience with counting whole numbers, this might make help it to situate it in a context. Can you slide us over? Okay. So here's another assessment question for you, just to get us thinking back into fractions specifically again. So we're asking you to partition this bar into 6 and then use that to show 5 6. So, and then we have asked again, think about how this question made you feel. If we were working together in a group, we would take some time right now to get you to physically do this, and we would walk around and we would take up a bunch of conversation. Yay, I love bar models too. This is a very powerful model, and it relates to linear models, which are similarly powerful.
So fold the paper.
So, I would say that some people might get that fractions anxiety, but some other people might think, ugh, this is silly or too simple or too easy. We've had that reaction quite a bit. Or my students, I wouldn't bother doing this with my students. They're going to know how to do this. But in our experience working in all those classrooms and with thousands of students, we were shocked at how challenging this was, even for students in the upper grade, even for students in secondary. And earlier in the chat, somebody had said, yeah, we use fractions, but we may get students to color in one portion of a divided image, which is what we've always done. Or we've used pre-partition shapes, right? And gotten them to either count it or color it in and identify the amount. We've rarely, and we've moved more and more towards this in our own teaching and our own models, to have the students create the model and do all the partitioning, because there's some very, very fine neurological things happening when they're creating this model. There's some very fine tuning about the amounts, the relations of the amounts, the partitions to the whole, and that kind of thing. We were so surprised how much this challenged students, but then when we thought about it and we reflected on our own practice, we thought, well, yeah, why would they know, how to do this? They have not been asked to create fractions in this way very much of the time. Is there anything else you'd want to say about that, Shelley?
There was a comment in the chat. I did respond specifically, but I feel like it's important. We really do want, and Tara alluded to this, but we really do want students to be using their estimation to calculate rather than going to a ruler and turning it into a whole number. I have 60 millimeters and I want to make 6, so it's a 10 millimeter, 1 centimeter, blah, blah. We really want them to be using their spatial reasoning to do this.
Yes, I was going to say, this is about spatial reasoning. If we take it to a ruler and then we start to get hung up, somebody had mentioned this, on perfection, and we start to get mired in the calculation aspect. That's not what we're intending to do here. We're working on creating opportunities for students to build their fractions number sense and to work with their spatial reasoning. So they're not thinking about calculating, they're thinking about the relationships within the model.
And there's some comments about precision as well. And I think, that's another great point, that it doesn't need to be exactly precise. If the students understand that they are equal sized pieces and they're not quite exactly precise in their model, but they understand they should be, then that's sufficient. So, okay.
Let's move to show.
Yeah, so some people said they do halves and then thirds and then shade it in. Sometimes students just start at one end and work across, and that's okay too. Whoop, that went really fast, but anyway, starting at one end and just working across. And let's just come back to the water in the containers question and think about how counting might, if you didn't have counting in your toolbox before, how you might actually approach this question now with your counting skills, just by counting 1 1/4, 2 1/4, 3 1/4, 4 1/4. Oh, I have 5 1/4, and getting your answer that way. And then we'll do the landing game again. So this time it's just a slight modification. So this time you're going to pick your group, and I would encourage you to stay with the same group that you used last time. And then select a unit fraction. So now you're going to count around twice and end at a value between 1 and 2. So I'll give you a minute to think about that. You can pop your information into the chat if you wish. And we'll wait.
I will just make a quick statement here about in response to somebody in the chat saying, what about people with challenges with spatial reasoning? As we might see in some students and in some adults. So we, alongside this fractions research, have also had a longitudinal study on spatial reasoning and mathematics with young children, which maybe we'll share next year. But so we have studied spatial reasoning a lot, and I can tell you that the literature says our research affirms that the great news is that spatial reasoning can be improved for all of us at any age, no matter our gender, no matter our neurology, with experience, with tasks that, with paper folding, for example, the 5-6 task that we just showed, this is great news because those experiences will build spatial reasoning. They will. And so it's not so much that we're testing people's spatial ability or relying on that instead of some calculation ability or something else. It's about building some spatial experience and spatial, like we're talking about reasoning, right? Some fractions, number sense reasoning, along with spatial awareness and reasoning. So they're building together is what I would say to that, to strengthen one another. And through the experience, your spatial reasoning will improve, even yours doing this now. We used to believe that spatial reasoning was a fixed ability that you were born with. A lot of the old IQ tests are built on this premise, and that is not at all true. The research has shown that spatial reasoning is fluid and can be improved at any age.
And I find even myself that I am getting much, much more accurate about the partitioning because I've just been doing it so much. So I feel like, and the fractions learning is in the partitioning. The research was very clear about that. So having students engage in this, and yeah, definitely struggle sometimes, but paper folding is a great strategy that we can't share with you today on this medium, but that you can definitely do in your own home. Very good strategy for using to use for partitioning, and then a very good skill to develop for students. Definitely carries them through in many, many ways.
So Shelley, I'm just noticing we have about 15 minutes left. I know.
We're gonna go.
So let's share, and we will come back to some. There's some really great questions, and honestly, I wish we were in a room together and we had a couple hours with you or a day with you. But we'll get to as much of that as we can. So we wanted to circle back to this counting. Why is counting by unit fractions important? We want you to think about how much whole number counting we do with young children. How much we count. We count our steps. We count skipping to school. We count the trees when we're driving by. We count the snacks. We count absolutely everything over and over and over. We never worry about, is there too much of this experience? We know that it takes repetition and so many multiple experiences for children to build number sense through counting. Through counting, we build a sense of ordinality. That's the order of numbers. Through counting, we build the sense of cardinality, which is the understanding that the number we end at is the total that we're talking about. So we build some really foundational understandings about quantities through counting. And yet we have never tended to do that with fractions. But when we do that by unit fractions, we do two things. We allow children the opportunity to tap into these strengths with their whole number sense and their whole number counting. So we're springboarding off that. We're building off that. We are also giving them a chance to build the sense, because this is what the research shows is the biggest barrier to students and adults understanding fractions and being able to operate with fractions and manipulate fractions. The understanding that a fraction represents a quantity is a gap. It seems so too simple maybe, but that is what the research shows that is a huge barrier in students' understanding, is that when we move into teaching about fractions, we get very symbolic in our representation. We move away from the things that we used with whole numbers to support their growth of their number sense. And so students might go through all of school thinking that a fraction is not a quantity or not making that connection, but that a fraction is some symbolic one number over another number. You do this and follow these steps and you get this, but not understanding what those steps, how they're impacting the original quantity. So counting by unit fractions builds that. Super, super, super important.
There's a couple of comments I'm going to jump in and just talk about. So here we want to show the counting. So yes, we could say that we had, 1/3, 2/3, 3/3, but we want to show that we're adding on or counting on the quantities. So we're not labeling the location as the value. We're showing a cumulative total as we count on. I hope that makes sense. Sorry, Tara, I didn't mean to jump
Oh,
in.
no, all good. So, I've basically said this already. So we move, just like with whole numbers, we through counting build a sense of quantity. And the next slide, we start to make sense of equivalent fractions because we're starting through the counting to see very naturally that there are different ways of naming these amounts that we're calling fractions. We might, and many of you have already shown this in the chat. This is 1 2/3. It's also 5 1/3. It's also 1 plus 2/3 or 1 plus 1/3 plus 1/3. So we start to sort of naturally make sense of equivalence of these quantities that we call fractions.
And then finally.
And with that, then we are moving towards operations very naturally. And some of you already evidenced that in the chat as well. By talking about this as multiplication. Exactly. If we're counting and our very next step is adding, and our very next step after that is multiplication as repeated addition. And once we have that, and we know division is an inverse operation from multiplication, our understanding of that can be built from a sense-making position, from a sense-making stance.
So
yes,
we have
Vivian, it makes a natural progression, just
absolutely
like whole numbers. Exactly.
So we have two resources we just want to show very quickly. First, free and available to everyone is this website called fractionslearningpathways.ca. And these are learning trajectories, and they are developed from the research by the classroom teachers. So you'll see we start with a focus on unit fraction. We talk about comparing and equivalence, and then into add, subtract. And below this, when you go to the website, is another whole sheet that talks about multiplication and division. These are dynamic cells. So when you click on one of those cells, you'll come to another page that has tasks, additional prompts, and a little bit of research. So we just want to say all of that is free and available to anyone, no matter where you are in the world. And there is a lot of information on that website. We took that information. That's just what the tasks look like. We took that information and boiled it down into 8 core concepts. And so you'll see the 8 core concepts span from the very early beginning of estimating proportions, equally partitioning, naming and counting, composing and decomposing, putting together and taking apart, partitioning unit fractions into smaller unit fractions. So can I find a value that's smaller than 1/3? Talking about density, getting into comparing, and then into the operations. So this is in the book. The one major distinction between the book and the pathways is that the book has all of the assessment questions that we used for our research to judge whether what we were doing was impacting student understanding. And we have scoring guides, student samples, and then tasks to go along with it. So we're not, we really want to give you tools that you can go back to your classroom and use, but we also just want to show quickly what's in the book. So we have assessment guides, assessments in the book that have questions. You've seen some, these are some other ones that we have. And then we have these scoring guides that you can code so that you can get some information about where your students are and sort of where you need to jump in. We really think counting, if you're not sure and you don't have the book, just go count with your students. It's so powerful. Once you get the data back from your students or you see where your students are, we make suggestions about what you might do for future support around that skill for those students. And then we have lots of information in those tasks, visuals and teaching moves and questions. So when you buy the book, you also get access to this website. And then on the website, you can download the images of the questions and any Blackline masters or templates that accompany the task. And we'll have information at the end with the book and then how to contact us. Okay, part 3. This is like down
this speed version.
Yeah. So what we also learned is we know that people love to teach fractions using pizza, but we say down with pizza because I have yet to see a pizza arrive anywhere and actually be properly equipartitioned. So we want to use models that students don't have to set aside their real life experience with them to make sense of them in the classroom. So set models, linear models, Cuisenaire rods, number lines, rectangular models that we've been showing, and volume and arrays. And so really encouraging students to use the number line is so powerful. We know from the research that we all have an intuitive number line, so tapping into that. And students have familiarity with number lines with whole numbers, so we can build on that.
And these are building familiarity to work with representations, to do the thinking, to manipulate and work with those quantities, to do the thinking rather than show us your thinking after the fact using a representation. And we know from our research and the research of others before us that, and alongside us, that those representations have legs. They go across concepts and areas in mathematics, so they're powerful in that way too. And Shelley's going to say a little bit about how to work with new versus familiar representations.
Yeah, so this was also from our very early meetings with the international researchers. Really interesting insight into precision. So we like to sometimes just be like, oh, you didn't get the whatever, let's do this, let's do this. And we sort of jump around. But what they said was, no, be very, very purposeful. So if you are introducing a new concept, go back to a familiar representation. So I've already said students often know number lines from whole number representations. So stick with that representation when you're first introducing fractions. But, and this was the one for me that I think I really had a huge impact in my teaching with students because I did this. So I introduced new representations with familiar concepts. So I backed up a little bit. Once they know how to compare on a number line, let's say, then we can use a rectangular area model to do the same comparison. So we're not saying, oh, today we're going to learn about comparing and we're going to use a whole new representation. And why not circles? You know, I've already alluded to the problem with pizzas, but also we don't teach students about the properties of circles until junior or even into intermediate. And we're asking them to use an understanding of area of a circle before they're ever instructed on that or have opportunities to develop understanding. So then we see things like this, where they're just partitioning into pieces, a count-wise approach without really thinking about what the equivalent region would be. And yeah, not friendly, as Cathy has said, not friendly for more difficult fractions. Rectangles and number lines are super friendly. If you mess it up, you can tack a little bit onto the end to fix it. You can't do that with a circle.
And they're complicated. They're complex geometric figures. And we're asking young students to work with them in a way that's beyond their understanding yet. When there are other great models that are so much friendlier, why not?
So I'm going to jump a little bit ahead, Tara.
I
And
would, because I think we have 3 minutes.
yeah, so I just wanted to talk a little bit about common denominators super quickly, and then we'll wrap up. So when we were teaching common denominators, when I was learning common denominators, I was taught you pick a number and you multiply the numerator and you multiply the denominator by that number. And what you do to the top, you do to the bottom was sort of a mantra that we've heard. And when we multiply something by 3, we're actually changing the size of it. So if I multiply 2 by 3, 6 is 3 times the size, but I'm using that rationale to generate equivalent fractions. Doesn't make a lot of sense. So we're saying just make this tiny little tweak. Instead of writing it the way you see at the top, write it the way you see at the bottom. We're going to multiply 2/3 by 1. If I multiply any number by 1, it doesn't change the quantity, and I would definitely have understood much more readily why 6/9 is the same quantity as 2/3. So really encouraging you just to make these little tweaks, and I see lots of people are doing that already, which is amazing. Okay, so to recap, we suggest using precise representations like number lines. Stick with a representation for a long time. Use unit fractions to help your students understand that they are the foundation and that they can count by them, which helps a lot. And then build counting in. When you come to addition, go back to counting. People are saying when they do radian measure, they go back to counting. It's great. And most importantly, have fun. So, in conclusion, if you wish to order a book, there is an email link, a telephone link, and a QR code which links to a PDF to download. If you're in Canada, you can go through the order form, and you can go through even Pearson Education website or contact a local salesperson. If you're outside of Canada and you're interested, just send an email. It's going to be the best way to get your hands on a copy if you wish. And I think we can share the slides. I did ask John, and I'm not sure if he answered. So
yeah, you can share the slides. So if you send me the link there by email, I'll upload it into the replay page area so that folks can go back there and they can get access to it.
perfect.
Great.
Awesome.
And then the last, so the email is on this slide to get the book. It's school_inquiries@pearsoned.com. And then the last thing we wanted to share is we have some social media tags and an email. So we are using the tag fractions teaching. We're on Blue Sky, Facebook, and Instagram, and we have an email. And I know there's door prizes. So I know, John, you have door prizes.
Yeah.
I think two books to give away too.
Yeah.
So can you help us with
so let's
that?
do this. Let's do this. So we'll give them all away the same method.
Okay.
So folks, here's what you want to do at this point. Get in the chat and tell everybody what your biggest takeaway from the session was. Like, think about all the nuggets of info, the gold that you just heard throughout this hour. get in the chat, take a moment and write us a little sentence, maybe an idea, maybe it was like just a feeling you had. Put that in the chat. And what Tara and Shelley are going to do, you want to give away 2 books?
Yes.
So 3 times what they're going to pick is 3 different like you can randomize it. Sometimes what we used to do is scroll and then just point, or you can read a couple and go, yeah, I want that one. So I'm going to leave it to Shelley and Tara to kind of like get in the chat there and have a peek around and pick out 3, and then we'll give away 2 to books and 1 that gets to the braining camp. I'm going to share my screen here. Just so because I'll do some reminders for folks while they're doing that. But I know it's tough to read them all, so you just kind of like stop the scroll with your cursor and then just pick one. Like it's almost like a spinning of a wheel in random draw.
Okay.
So think of it like that. The third prize that we give out here is a branding camp license for 1 year, and we'll make sure that you get that. Now, if you get picked, folks, all you got to do is hit reply on one of the emails that we've sent you. You're probably going to get bunched today because you're going to get an email for every session you signed up for. So just any one of those, hit reply and let us know, hey, I won the free book, or I've won the branding camp license from Tara and Shelley's session. And then Tara and Shelley, I'll relay the book winners to you so that you can kind of make sure that they get what they get. So while that's happening, a couple more reminders, folks. Tickets, if you need to extend past the weekend, make sure you go back to the site, add a ticket. You can do it anytime out through the weekend. Just do it before the weekend ends so that you can make sure you continue that access. Again, certificates, you probably are seeing that if you've attended a live session, you're going to look at your certificate in your account. It probably is not showing you exactly your attendance for those live sessions. Don't worry. We'll make sure that we're going to do what we did last year, which is on Monday, we're going to send out information on how to actually generate an accurate certificate so that you can get credit for it. So don't worry. No need to reach out to us. The other thing, because this was specifically about fractions, just as a heads up, we are running another free session next month in December on connecting fractions, decimals, and percents. Our coach here, Yvette Lehman, is running that session. You may have participated in the sessions we ran in November on fractions, and in September or October and September on fractions, and specifically division. So you can register over there for free right now, makemathmoments.com/training, or go to our website, makemathmoments.com, find the training link up in the top menu. You can register. All of our other events are there to register. Every single month, all year long, we're running training on a topic that's going to be important for you and your students. All right. How are we doing? How are we doing? What do we got? Do we have 3?
Got one, Tara?
Oh,
You just kept reading.
I got distracted.
I'll start us off. Are we going to
Okay.
do a book or?
Let's do a book first.
Okay, I think it was Ms. Mahoney.
Ms. Mahoney. All right. Congratulations, Ms. Do you have it in front of you, Shelley? Do you want to read it out? Or is it gone?
How to spell it?
No, the comment they wrote.
Oh, no, I don't.
Okay. Ms. Mahoney.
Actually, I just scrolled. I didn't.
Yeah,
I
it's
scrolled
okay.
and just picked a
Ms.
name.
Mahoney, all you got to do is hit reply. Let us know you won the book from Shelley and Tara's session. All right. Tara, you ready? Another book.
Subi Hitaku.
Subi. I'm just going to write these down. Subi.
The comment is counting the unit fractions is so important. You need to have students say 1/1/4, 2/1/4, etc.
Totally. That's a big takeaway for me. Okay, Subi, make sure you reach out to us. Tell us you won the book. All right, we need one more for the Braining Camp license. Free license for Braining Camp coming your way.
Over to you, Tara.
Okay. Christine says, need to spread this book to other coaching colleagues here in NL. Is that Newfoundland?
Ooh.
Oh, good.
All right, Christine from Newfoundland.
Awesome.
All right, let me know. Send me an email. Say I won the Braining Camp license. We will hook you up throughout the week to get access to that. All right, folks, we are continuing running sessions throughout the weekend. Thanks so much for joining. You can go back to the site that you just came from at the beginning of this hour. You can pick, say, any sessions that's running right now. We just started another one. There should be probably 2 running right now, or check your schedule. You can always see what's coming up. We've got lots coming up today and tomorrow. Thanks, everyone. We will see you next time. Thanks, Shelley. Thanks, Tara. We'll be in touch.
Thank you
Yeah.
guys so
Thank
much.
you. John, can we get the note, the